Okay, our next presenter is Tae-Han Kim from IML Company in Korea, and he is going to be talking about VC2 compressed video and ST2110. So, welcome.
Okay, okay. Hello everyone, and in this talk I would like to present IP workflow development with ST2110 and another compression, VC2 compression technology. Okay. My talk will cover introduction to the testbed we developed so far, and the SDI to IP converter that is used in the development, and the codec technology that is used in development of the converter. And the next one is audio over IP, which is somewhat different from the ST211030 standard. And finally, we'll discuss about our results. Okay. This photo shows the panoramic view of the test bench workflow we developed. It is placed in the KBS. KBS is Korean Broadcasting System, which is national broadcasting company in Korea, which is the largest one in Korea. And I'm sorry about the small Korean fonts in the photo, but it contains spine lip switch at the left of the corner, and a P2P generator from Tektronix, and SDN manager server, and NMOS manager server, and video IP monitor equipment from Tektronix, and IP supporting video recorder and video generator. And it also has SDI output CG, computer graphics server, and it contains also IP supporting video switcher, 4K video switcher in it. And we have 211020 supporting SDI to IP video converters and vice versa. And also 2110-22, a VC2 codec supporting SDI to IP converters in it. And also 12G SDI cameras and SDI multi-view monitors. And we also have miniature studio in it. So, who built the workflow? There are four companies in the consortium for building new test bench. KBS developed the whole architecture of the test bench workflow, and it is the test bench holder. And KBS also developed 2110-2030 supporting media server, computer-based server. And Lumentech developed its 2110-20 supporting video switcher, 4K video switcher. And it also developed a web-based workflow manager. And the third one is Atto Research, which is the #1 SDN solution provider in Korea. They developed open flow-based SDN switch and network architecture that can be applied to company-wide network infrastructure for video network. And the last one is IML, which is from I am from, and we developed compression-based SDI to IP converter. And we also developed workflow manager, standalone workflow manager software, which is running on a Windows operating system. Then why four companies built this test flow? KBS is already operating a full IP-based workflow studio in it, and it's from Grass Valley Cisco solution. And some of you may already know that they are using some proprietary network solution and Tico compression in it. And KBS wanted to develop ST21 interoperability with legacy SDI devices and new IP technologies. And also, switcher making company Lumentech wanted to extend their SDI-based technology to IP-based one. And also, we wanted to use 10G devices. We cannot trace all 10G supporting network switches in a day. So we wanted also compression-based IP solution. So we adopted VC2 codec. At the start of our development, VC2 was the only codec that has been released at that time. And also, it's free. Yeah. And for network infrastructure, we wanted to have broadcasting company-wide IP network connectivity, not only supporting the servers and computers, but also that can cover all the new IP video streams and audio streams in it. And also, we wanted to have IP solution that can manage assets and all hardwares in the company. That was our purpose of the development. So for that development, we adopted ST2110 open SMPT standard for media transport, and we used NMOS protocol stacks for workflow management. And the target media is UHD at 59.94 frame per second, progressive. For your reference, in Korea, terrestrial TV programs is running with this resolution every day. And about audio, actually, we could not follow up 211030 fully for this development, but we wanted to regenerate the original SDI frame that contains embedded audio in it. So we transmitted 16 channels of audio, embedded audio in the SDI source through the IP standard, which was originally developed for ancillary data. I will explain later. Okay, and as I told you before, there are so many 10G supporting network switches and routers and so on in broadcasting companies. So we built a spine lip design, a simple spine lip design that can be extended, which have 1G and 10G and 25G and 40G, 100G Ethernet switches in it. And we wanted to develop the network backbone with non-proprietary SDN, such as OpenFlow. And it should support legacy IGMP. As you know, in the IP workflow, multicast streaming is the basic key in network structure. And for video coding, 2110 uncompressed transmission, and also at the same time 2110-22 compressed transmission both exist, coexisting design we developed. And for compressed media streaming, we followed IETF draft for VC2. And these slides shows all the components in our test bench workflow. The source is generated from Miniature Studio and SDI camera and SDI supporting video servers and CG servers. And we also adapted PTP generator from Tektronix because in the workflow, there are some devices that require the PTP information. Actually, in our development, not all the devices require PTP timing information. I will explain in the later slide more about this. And we have multi-viewers and monitors and IP-based video switchers. And in the background, there are spine lip network. And all above these components, there are network managing server and NMOS management server. And this is the simplified block diagram. And at the left of the slide, you can see SDI cameras and video recorders, which only transmits its output with SDI cable. And for uncompressed transmission, we developed the 2110-20 supporting SDI to IP converter. And it uses 40G Ethernet. And for compressed video compression, we used 10G Ethernet network structure, network cable. And the core element of the live studio is, as you know, is video switcher. And in this development, we developed our own 211020 supporting video switcher. And it uses multiple, actually 2 lines of 40GE Ethernet connection. And we can receive from SD21-20 converter for uncompressed streams. And we can receive 211022 compressed streams with compression-based decoder. And about the compression-based encoder, this slide shows the simplified diagram of our development. We developed our own FPGA solution, hardware and logic and firmware on this hardware. And the received SDI stream is divided, demuxed to have video streams and active audio streams and ancillary data streams. And video stream is encoded with VC2 codec. And actually, in our development, we used 2110-40 for audio transmission because our purpose was somewhat different. Our purpose was to exactly regenerated audio embedded SDI stream, SDI frame. So we thought it would be better to transmit original audio packet in SDI frame contained in 2110-40 packet. So it is the difference. And auxiliary packet, currently we are not transmitting auxiliary packet data. Actually, we didn't determine how to use auxiliary data in IP stream so far. And actually, it is packet boxed and Ethernet framed, and it is transmitted over tangent network. And also in FPGA, we developed our own firmware stack that supports NMOS without any operating system support. It is only embedded. And also in VC decoder, it receives from tangent Ethernet network, and it filters. And actually, in IP workflow, there could be many floating streams that is not fixed to some direction. So Ethernet filter is very important in decoder implementation. And we demuxed each packets into video 1 and audio 1. I'm sorry about the audio streamer packetizer. It is not 2130, it is 2140. I'm sorry, it's typo. And the decoded video stream and audio stream, depacketized audio stream is buffered and regenerated SDI. And also in decoder, timing synchronizer is implemented. As I said before in my presentation, VC2 transmission does not need any timing information from PTP. So we need to regenerate the original timing from the input source. But the input source is not SDI and it's Ethernet packet. So we used some technology for finding out the original timing information from Ethernet packet timing. So another development is our ISO 04 and ISO 05 support a workflow manager. It's operating in Windows, and it shows icon view and matrix view and device view for connection management. And this shows what kind of technologies are used in our compression technology, compression. And input is SDI, 12G SDI. And we used wavelength slice and filter like 64 by 2 Luma wavelength size and Lugiel 5.3 filter. And we also support HAR0 and HAR1. And compression ratio is dynamically configured from 4:1 to 20:1. It is extended from this slide. And the important thing in our compression is that it is slice to slice exact CBR. It is different from some other low latency codecs. It guarantees even video quality all over frame. Okay? And the total latency of encoding and decoding, and important thing, which is not mentioned generally, including buffering, we have 20 microsecond delay in total. And our implementation can be found in the Xilinx link below. And our codec structure can be displayed like this slide. Actually, almost all low latency codecs have similar structure. However, they say much more thing is different, but they use discrete wavelength transform and slice indexing and packetizing, entropy coding. But some recent codecs uses some more technology like frequency in coefficient space. They use some envelope encoding and decoding. So it can cause better PSNR. But VC2 codec we implemented have quantizer pipe structure. This is a very important thing in our implementation because the standard itself does not define the encoder structure. But by using quantizer pipe, we can have exactly same CBR from slice to slice. Every slice in a whole frame have the exactly same compression ratio. And it is LTP packet transmitted. It follows IETF draft, and it is continued as SMPT 211022. And fixed number of compressed slices are packed in a payload. And there are 3 types of packets in our implementation: 2 header packets and compressed video packets, like this. And time synchronization. It is very important point and important part of IP workflow development. Actually, in our encoder development, no PTP timing information is used. Our strategy is minimum latency from pixel input to LTP packet generation. That is our strategy. So, no framing timing sync for LTP stream. And decoder regenerates the original SDI video timing from input packet. And also, there are many types of encoders and decoders and uncompressed one, compressed streams. So we need to differentiate. We need to know which node is compressing and which node is not compressing. So we used STP-Pile to find out which device is compressed one. And this slide shows why we are using minimum latency transmission strategy. As you know, if you need to phase synchronize from node to node in IP workflow development, it can cause multiple frame delays at the end of the transmission. But if we follow the input stream without any buffering, we can have only 60 lines. For example, if there are 4 IP nodes in it, we only have 60 lines of delay. And for audio transmission, as I mentioned before, we used 21-40 transmission technology. And I'll pass. Okay. The original audio packet in SDI frame is transmitted over 21-40, and the active video is encoded and transmitted and decoded. So audio packet arrives earlier than video packet. So we can exactly regenerate it by looking for the line number of the SDI frame so that we could be able to regenerate the original SDI frame. It is similar to previous 2022 technology, but this uses video compression. That's the difference. And this is finally, I'll talk about what we got from the test bed. We wanted to know the interoperability of legacy SDI devices and newly developed 2110 supporting devices. It's working fine in our test bed in KBS. And we found that unified management is required. So legacy SDI devices should be NMOS by some IP converter. IP converter should support information about the SDI legacy devices. And we found that not all devices need P2P synchronization. Actually, in our development, Matrox card and some Mellanox software stacks require the P2P information, but other devices actually do not need have P2P information. And for future works, we think that application of the latest and new NMOS standard, like actually ISO 4 and ISO 4 is have newer version of standard, and actually 06, 07, and to 10 we need to apply. And actually VSF generated full stack standard for corporate-based workflow design. And actually for VC2 codec, we are contacting BBC for enhancement to have better PSNR. We would like to use our resource if it is possible to have that chance. And for workflow manager, we would like to open our source for co-development of our workflow manager software with other companies if it is possible. And thank you for listening.
Okay, thank you very much. So I'd like to find out if there's any questions from anybody in the audience. One thing I was wondering, with respect to VC2, how many other implementations have you seen? Are you do you see interoperability with? Have you tested with you know, some of the some other implementers of VC2?
I'm afraid not yet.
Okay.
Yeah, because we developed our own codec in-house, so we could not have chance to test interoperability of VC2 codec from other company.
Do you see that as something that's important going forward?
Yeah, it could be, but actually, compression-based transmission requires encoder and decoder.
Correct.
So if they are paired, the interoperability from other codecs is not that important, I guess.
Understood, understood. Okay. Anybody else? Any other questions? Yeah, hold on.
Could you just explain again the reason why you were using 211040 for the audio? I understand what you did, but not why.
Because I said in my presentation, it's not standard following, yes? But we wanted to regenerate the original SDI frame, and we wanted to have exactly the same place of the original audio packet in SDI frame. Because the legacy audio devices supporting SDI, we wanted to have exactly same result. That's why we used 211040. But we could have other protocol, but at least we would like to follow some standard in it.
Any other questions? Okay. Our next presentation will start in about 5 minutes. Just wanted to remind everybody, if you're interested in getting a link to the presentations, feel free to stop by the front desk and have them scan your badge. Also, the videos of this will be posted on the VSF YouTube web channel. And also, if you go to vsf.tv, you'll see a link up there in the very near future that will point you to where all the videos are located. So thanks, and we'll have Erling come on in about 5 minutes. Thank you.